Question number 8 says, if f of x equals to 3x to the fourth plus 12x squared plus 12x minus 11, you want to find delta y and you want to find dy when x is on the interval from 3 to 3.5. Now remember, we can approximate the change in y, which is delta y, by using the differential, which is dy. Now, to find the change in y, or delta y, we call that the net change. And the net change is equal to the function evaluated at b minus the function evaluated at a on some interval of b and a. I also want to bring something up, which is called delta x. Delta x is referred to the change in x. And to find the change in x, you can do it both ways. Well, two ways, I should say. The change in x is equal to b minus a, such that b is equal to a plus delta x. Makes sense. If I just switch the order, I'll have what I'm looking for. If I add a to both sides, we have a plus delta x. Keep that in mind. So let's first label our a and our b. A is 3, b is 3.5. To find the net change, or to find delta y, that's going to equal to f of 3.5 minus f of 3. Let's plug 3.5 into our function, plug 3 into our function, get those numbers, and then subtract them. So f of 3.5. I'm going to use my calculator to plug that in. So remember, we're plugging 3.5 into the function. Let's put the calculator over here. So that's going to be 3 times 3.5, close the parentheses, raise that to the fourth power. That's going to be plus 12 times 3.5, close that up, square it. Plus 12 times 3.5, close the parentheses. I meant 3.5. Let's just delete this and write this again. And then that's going to be minus 11. And that is our value. Take all the numbers after the decimal. 628.1875. Now, let's find f of 3. In the same way, we're going to replace our 3.5s with 3. So delete the 0.5 here, delete the 0.5 there, delete the 0.5 here, and that equals to 376. So to find delta y, there's going to be f of 3.5, which is 628.1875, minus f of a, or f of 3, which is 376. And let's calculate that. 252.1875. This is the actual change in the y values. Now let's find dy. dy is a differential. Remember, suppose y is a function of x, and we take the derivative of that. So dy over dx equals to f prime of x. If I multiply both sides by dx, or the differential, those simplify out. We have dy equals to f prime of x times dx. And for our differential, we can say that dy is equal to f prime of a times dx. And what is dx? Dx is also the change in x. So we're going to take the derivative of our function. Let's find our first derivative. The derivative of 3x to the fourth power is 12x to the third, plus the derivative of 12x squared is 24x. The derivative of 12x is just 12. The derivative of 11 is 0. Now we're going to plug 3 into our derivative. So f prime of 3, because remember our a is 3, is going to equal to 12 times 3 cubed plus 24 times 3 plus 12. F prime of 3 cubed is 27 times 12. That's 324. 24 times 3 is 72. And we're adding 12. And we get 408. So to find our dy, it is f prime of a, which is f prime of 3. That's 408. Times dx. Well, what is dx? Dx is the same as saying delta x. So dx is b minus a, which is going to be 3.5 minus 3. Dx is 0.5. So we're going to multiply that by 0.5, which means dy equals 204. And that's going to be used as the approximation for the actual change in y. All right, guys, that's it to the video. Hope it made sense. Take care.